Hello, good afternoon everyone. Welcome back to our new session. The last topic of rational numbers, that is the chapter name is real numbers. I told you what is the last topic, revisiting irrational numbers. So what are irrational numbers? Which cannot be expressed in p by q form. Nothing but non-terminating, non-repeating decimals. Again I'm repeating, what are irrational numbers? Which cannot be expressed in p by q forms, where q is not equal to 0. And they are non-terminating, non-repeating decimals. If you see the perfect squares, what are the perfect squares? 1, 4, 9, 16, 25 and so on. They are rational because they are perfect squares. What about the numbers which are not perfect squares? What are they, sir? Root 2, root 3, root 5. These all are not perfect squares, so those are irrational. And in this session, we are going to prove that root 2, root 3, root 5 are irrational. Let us do with one question of root 2. Okay, let us start the class. So now, prove that root 2 is irrational. We are supposed to prove that root 2 is irrational. Then proof is that we need to assume it is rational. In order to prove it is irrational, we need to assume it is rational. As soon as you assume it rational, and root 2 should be equated to a by b, where b cannot be 0. Because when b is 0, it cannot be defined. So b should not be equal to 0, and this a and b are integers and co-primes. Integers means you already know it has negative number 0 and positive number, but condition b should not be 0. Co-primes means HCF 1, means the common factor is 1. So this point you remember co-primes, and we are going to discuss on this because it's going to be key factor in this. Now when you do squaring on both sides, this square and root will cancel each other because squaring on both sides, square and root will cancel each other. So 2 is equals to what? A square by b square. Now from this, if I want to write the equation for a square equal to what? 2b square. If you send 2 to other side, it will divide. So what is our b square equal to? A square by 2. What is our b square equal to? A square by 2. Now according to a theorem, if this division number is a prime, we have a theorem. If p is a prime, if it divides a square, then it also divides a. This is our theorem 1.5. So same way, this 2 is a prime. If it divides a square, then it also divides a. Clear? So this is the point number 1 to be noted. The next one, we need to continue with a is equals to 2c, where c is some integer, c is some integer. Now again the squaring concept, a square, 2c whole square. A square will be a square only, 2c whole square will be what? 4c square. Now from here if you see, a square is equals to what? 2b square. In place of a square replace. So 2b square is equals to what? 4c square. Now again cancellation, 2 1s are, 2 2s are. So b square is equal to 2c square. Again same way if you rewrite for c square, it will be b square, but again same theorem. If 2 is a prime number, it divides a square, then it also divides a, because the theorem, the same concept is applicable. If 2 is a prime number, if it divides b square, then it also divides b. So this is our first thing what we got. This is the second thing what we got. Here we got that both a and b has 2 as a common factor. Correct? But what we took? A and b are co-primes. But we got they are not co-primes, they have HCF as 2. Why this arisen? This problem came only because of we assumed root 2 is rational. Because we assumed root 2 is rational, this problem arises because they got a HCF as 2. It should be 1, but it got 2. So our assumption is wrong. So we conclude that root 2 is irrational, and hence our question is done. And the same pattern is applicable for root 3, root 5, root 7, root 11 and all. So 1, 2, 3 are all going to work in the same pattern. It may be root 7 and it may be root 11. Now, so what about this question, or this and this? They are going to be worked out in a different pattern. We are going to watch it in the next video. Have a good day. Thank you.